read it, then you can help out.
Yeah.
4, that's what I got at the top of this page, number 4.
Yep.
Okay, the following list of 25 best devices. What's the rest
List
of
of
that?
25 test scores was recorded from a math class.
Okay. And okay, so 5 columns and 5 rows. Okay, I got it. If Sam's score is 91, and what percentile did he score? Okay, let me ask you a couple questions also. Do they require the Inspire, or do they allow you to use the TI-84?
They require the Inspire.
Okay, good. The one, I guess that's good. The one problem I had with this book that I got, it was an older edition, and all of their calculator stuff was based on the TI-84, and the Inspire is completely different. So I'm going to need a little bit. That's why I need it in advance.
Yeah, okay.
So far, I haven't mastered the calculator aspect of stats at all. So maybe you can help me out here. I suspect you know it.
Yeah, I do. We've been doing this for a couple days now, as far as just inputting data.
Let me turn it on, and if I have questions as to how to get stuff, maybe you can help me. Although I can always go to YouTube. If you don't know how to do anything on the calculator or a single thing, you can always go to YouTube and they'll show you a little 5-minute video of how to do it. Okay.
Yeah.
That's the way I'll teach myself how to use the Inspire, because I have an Inspire and I don't have the TI-84. So, okay. So the first thing you did was, did you use your calculator on this problem?
Yeah. So what I'm doing right now is I opened a new document and opened a list in spreadsheets page.
Okay. I do have a question.
Yeah.
Is there, I get the sense from the book that I'm reading that if I went to their website, I wouldn't have to manually input all of this stuff. That they would have a file that would automatically fill out your lists, and then you could just run the statistical app. Am I wrong there? You had to manually fill it out?
Yeah, I had to manually fill it in. I'm not aware of any.
Okay. All right.
But basically what I did is that just input the data in whatever order, because it's a lot more work to put it in order manually.
Right.
And then what you do is you name the column that it's in, like a variable like X, and then you just press all the way up, press up, and it should highlight everything.
Okay. I'll figure out how to do it.
Yeah.
At least now that I know that I have at least one student that uses the Inspire, well, then I'll be motivated to figure out how to do this stuff.
Okay.
And I'll spend the next week figuring out how to come up with some of these things. I assume you know how to, are you going to answer every one of these questions from your calculator, or does any of this require manual stuff?
It's pretty much all from calculator.
Yeah. Okay. Let's see if I can, let's go through the logic of it, because that could be important, and that might be the only thing I can help you with today. In other words, you know the calculator better than I do at this point. Okay. So what I'm going to do, if I was doing this by hand, is calculate the mean. Add the 25 scores up, divide by 25. Got me?
Mm-hmm.
Okay. And then I need a Z-score of 91%, right? In other words, what the Z-score says, if you go to a table, in other words, what kind of table do you use for the Z-score, or does your calculator do it?
Isn't Z-score the number of standard deviations?
Yeah. In other words, Z minus the mean.
Yeah.
divided by the standard deviation, S.
Yeah.
Okay. So
The score here wouldn't be a Z-score, though.
no, but whatever the Z-score is, that means that 91% of the graph is to the left of where that is.
Okay.
And let's talk about that for a second. Let me do this here. Let me draw a bell curve.
Oh, okay. I get what you're saying. I thought you were relating to the problem. Okay, I was just reading the problem.
Yeah. In other words, the main thing that I'm sure you've learned is you have your mean. X bar, is that what you use?
Mm-hmm.
And then you have your one standard deviation away, which is X bar minus sigma. And then you have here, which is X bar plus sigma. And then you go 2 sigmas and 3 sigmas. And the one thing that I'm sure you've learned by now is that 68% of the curve, the area under the curve, lies between plus or minus 1 sigma.
Mm-hmm.
95% between plus or minus 2 sigmas, and 99.7% plus or minus 3 sigmas. However, Z is slightly different. If my Z is there, that says 91% of the data lies to the left of Z.
Mm-hmm.
Now, hold on a second. Let's see. Let's see. If the Z-score was 1, it would be right there. Right? Or it would be right here. If the Z-score was plus 1, then it wouldn't be 68% of the data that lies to the left of Z. It would be basically 34 plus 50. You understand that?
Mm-hmm.
In other words, 84% of the data would lie to the left of that Z-score. And the way I just get it is everything over here is 50%, and I know that's 34%. Okay?
Mm-hmm.
But if Z is not a whole number, then you need a table to tell you what percent of this section of the graph, basically, we're talking about. Because this is a Z of 1, that's a Z of 2, that's a Z of minus 1. And if you look under a Z table, you'll find the area to the left of that Z mark. So we want a Z-score that gives 91% of the data to the left, 9% to the right. Out of curiosity, how did you do this?
So for overall, if you're just asking Z-scores, sorry, I've both been paying attention to this and doing my homework at the same time.
That's okay. That's all right. I'm a little bit, like I said, I'm still working on this.
No, you're good.
But, and I might be actually wrong here. Let me think about this.
So the way that
Go ahead.
it's easy to think of Z-scores is that it's just your measurement of how many standard deviations you are away from the mean.
Yeah, I got this wrong. It's this.
Yeah.
So
that's your Z-score.
The X value minus the mean divided by the standard deviation.
Yeah.
So do you know what the mean and the standard deviation are for this table?
Yeah, so for this table, I haven't actually calculated it out. I can do that real quick, though.
Can you do it? I'm curious. Let's work from that point. Yeah.
Let me do it real quick. 6110. Okay, so the mean is 80.28, and standard deviation is 15.3.
Okay. So what we want, if I understand it correctly, let me erase this. This is the score that we're looking for, x, minus the mean divided by 15.3. That's going to be our answer as long as the z-score corresponds with 91%.
Mm-hmm.
Now, that doesn't mean z comes out to be 0.91. What it means is that when you look in a table, so I'm going to look in my table A, and I'm going to look for 91%. Have you ever seen one of these tables in a book, or are you strictly working on your calculator?
I'm pretty much just strictly working on my calculator.
Okay, well, here's what we
for the most part.
Here's what we got. If you look in a table, in this particular book, you open the inside cover and you see the Z table, the standard normal probabilities. And I look for 91%, and that Z-score is 1.34. In other words, if Z is 1.34, that means 91% of the area will be to the left of that Z. So that's pretty easy. We can do that math. So we get a Z-score of 1.34 has to equal what the score we're looking for, minus 80. I'm going to round everything off just to be easy here, since you're not doing it manually, but I want to make sure you know how to do it manually.
Mm-hmm.
And now, let's see, if I go to my calculator and I solve that, let's do that. It's 1.34 times 15 plus 80. I get 100. I get more than 100. I get 100 point. No, I didn't. Hold on, just a second. Oh, wow. Oh, I didn't divide it by, or add 80. Yeah, no, I got 20.1, and then when I add the 80. So according to this, x has to equal 100. In other words, if x were 100, you would have a z-score of 1.34. And when you look in your table, a z-score of 1.34 tells you that 91% of the curve is to the left of that. Understand?
Makes sense. Yeah, it makes sense.
Okay. Now, why we got, maybe it's because I rounded off. Yeah, that, no, if I use 15.3, it's going to make that number bigger.
Might be relevant. Something Valeria said to us today was that generally in statistics, no matter if it's below 0.5, you want to round up.
Okay. Well, I think we're doing this problem correctly.
Yeah. No, I think we're doing it correctly.
Okay. Even though we got this weird answer, and that could be round off error or whatever, but I suppose you could also interpret this as saying that you need to score 100 if you want to be in the 91%. But if we look at that table, I don't see any hundreds. So clearly, if you scored 100, you would be in the 99th percent. So not quite sure why I'm coming up with this answer. I'm almost positive I'm doing it correctly. But anyway, let's go to the next one. Would you come up with an answer out of your calculator, just out of curiosity?
For Z-score?
Well, for the 91th percentile. What score would score you in the 91th percentile? You know, there's another way to do this manually also.
0.91 times 25. So that's 22.75. So the 23rd position.
There you go. That's the other way to do it. In other words, you don't have to use Z-score. What's you took 91% of 25, right?
Yeah.
And you got 23?
Yeah, the 23rd position is like the 23rd on the list.
So the 23rd highest score is what?
It's 95.
Okay. And that is the 95th percentile.
Yeah. And how we learn to do the percentiles?
First percentile. That's 95 would put you at the 91st percentile. And that's absolutely correct. But the one thing you got to understand about statistics is it is not a math. It is a combination of art and science. In other words, there's lots of ways to come up with these, and they don't always agree precisely with one another. You did it the most logical way, which was to figure out what the 23rd score was. Now, I'm supposed to be able to get that same answer by using this technique. Now, why I got 100 instead of 95, I'm not sure. But both of them, basically, it's possible for two different methods like that to give you two different answers. Happens all through statistics as I'm learning. So, okay, I like the way you did it. That's almost the clearest way to do it. Give me that mean. The mean again was 80. And again, I'm going to round off, and the standard deviation was 15. I don't want to deal with all this.
80.28 and...
All right, 80.3 and 15.3, right?
Yep.
Now, part B. Somebody scored a 68, right?
Sorry, wrong page here. Yes.
Okay, so what percentile is that? Okay, I feel like you gotta do that.
Yeah.
In other words, which position is 68?
It's the 8th percentile.
So which position is it out of 25 scores?
Position?
That must be the 12th position. No, that would be the 50th percentile.
It's the 3rd position.
3rd position, okay. And 3rd out of 25 is the 68th percentile. So, hold it. No, it isn't. It's not the 68th percentile. It is the 68 was his test score, and you've calculated.
Oh, it's the 8th percentile. I'm sorry, not the 68th percentile.
The 8th percentile. That makes sense. Okay, I got you now. Okay.
I just said 68 because I was.
Yeah. And the way she's solving these in class is this technique, not the Z-score technique?
Yeah, we're using calculator lists.
Okay. But I think there is a difference. When I'm reading my book, there's two ways to answer these questions. There's one way, the way you're doing it, to find that it's the 3rd out of a list of 25, or the Z-score method. And the Z-score method is a little more complicated. As you can see, you have to set up the equation, and then you have to look in a table or on your calculator. But I think you definitely get different answers. So there's not the precision in statistics like there is in other maths. All right, so question number C. She scored a 70, what is that, 77?
Yeah.
Okay, I'm sure that you've got that figured out, because doing it the way you're doing it is really a pretty easy way to do it. You don't have to use the Z-score method. If we had a bigger list, in other words, having only 25 numbers is a pretty small sample. I'll bet if we had 2,500 numbers and they fit a normal distribution, then Z-score would give you the same number as this thing does, or at least a lot closer. The fact that there's only 25 numbers in this list, then I can definitely understand why one method doesn't give you the same answer as the other. In other words, one way to explain that would be, imagine if one of these scores was 2. Okay? Mm-hmm. That doesn't affect your percentile on anybody, right?
Mm-hmm.
In other words, your third from the top is still third from the top. Third from the bottom is still third from the bottom, even if you make the worst score a 2. So the way you're doing these, your answers would be exactly the same. But the way, if you use a Z-score, not going to be the same. You're going to get a different number because the mean will be different. In other words, that one value that's an outlier, a 2, is going to change this mean. And it will not change your position in the list. Whereas if I change your mean, it definitely changes the Z-score, and that changes the percentile. You get the percentile from the Z-score. Okay, just to let you know. Okay, let's see. So we don't need to do that one. That's just a question of making a list of the 25 numbers and figuring out which position you're in, right? Okay, so let's look at D. If Larry is in the 60th percentile, what was his total score? Well, what'd you do? You multiplied 0.6 times 25, right?
And then there's 2 different ways that she taught us to do it with the calculator. It all depends on what that comes out to. If it comes out as an even number, like a whole number, you go into it and you find the number. So if I did the 0.6 times 25, it comes out as 15. Go to
so wouldn't that be the 15th position in the list?
15th position, but since you're not rounding up, you have to find the average between that and the preceding number.
Okay. In other words, the answer really is the average between the 14th and the 15th position.
The 15th and the 16th.
Oh,
preceding.
Oh, right, because then any score between the 15th and the 16th position would have 60% of it to the left of the thing. Okay, I get it.
And so that'd be 86 and 88. So if I go and add 86 and 88, divide by 2, you'd get 87.
Correct. And 87 would make it precisely 60% of the scores were less than 87. No ties. No ties even. Because the 60 percentile exactly was an 86. Okay. So actually these are pretty straightforward and pretty easy to do this way. And the other way she taught you is probably using that formula.
Yeah, but we're basically like using the formula, but just using the calculator as a shortcut.
Right. But you're basically doing this. The Z-score is your score, which we'll put 87, minus the mean, divided by the standard deviation. If we look that up, that's a Z-score of about 0.5. And if I look up in my table, 0.5, I get 69% of the data is to the left of that.
We actually have a different formula for finding percentile.
Okay, what is it?
So you count up the number of values that are less than X. So if you're...
That's the way we've been doing it, right?
I think so, but you're talking about kind of doing it as, like, with using Z-scores with the formula.
Technique, and I'll bet you this is what, when your teacher had you use two techniques on the calculator, this was it. When you used the second technique on this previous problem, what'd you get?
So the two technique thing was for if you're converting percentile to score.
Oh.
Or yeah, you're right. Okay. So, okay, sorry, I was completely looking at the wrong thing there. So it was percent times the total number of values.
Right. So
which is just round up.
60% times 25. That's what we did.
Yeah. Yeah. Okay. Sorry, I was looking at the wrong thing.
So there has to be 15 scores below your score for you to get 60th percentile. And that is the easy way to do it. But if we had a big, huge table, more samples, the Z-score is a different way to do it. It's probably more valid. In other words, here's the problem. Now, let's talk about this for a moment. I feel bad that anybody that I tutored in statistics last year. Did we do any tutoring in statistics at all?
We did a little bit. We had a brief unit. There was a brief unit in algebra 2.
Yeah, I gave everybody the wrong answers. I feel terrible. I didn't realize it at the time. Okay, here's the mean. I know that 50% of the curve is there. Here's one standard deviation away. That's got to be, what's half of 65? 37 and a half, 20, 37 and a half? No, 32 and a half. So that part of the curve is 32.5%, right? In other words, this part is 50%. This part, 32%, 32 and a half. Because I know plus or minus one standard deviation is 65%. So from here to here, that's 65% of the area. All right? Now, let's say, okay, our mean was 80, our standard deviation was 15, so this is 65. This is 95. 65% of the scores are going to lie between 65 and 95. Okay?
Mm-hmm.
What have I said to you? And this is 80. What have I said? What about this point right there? That score is 87. I cannot take half of 32.5%. This is a calculus problem. And this is why I screwed it up last year, because I knew none of you had calculus. So I didn't know how they expected you to do this. Because area under a curve, it's not just 50% of it. In other words, the scores from 80 to 87% are not going to be half of 32%. This is more area than the other half. So you can't just divide that in half. And the way they handle that when you're pre-calculus and you haven't had calculus is they use the Z-table. That's the whole point of a Z-table. If you had calculus, you would not need a Z-table. That's the gist of it. But to figure out this precise area right there, in other words, I know 50% lies to the left of that, right? So if I can figure out the precise area between 80 and 87, then I have a percentile for 87. Whereas without a Z-table, I can't do it. Now, notice that I would not be able to use your technique that we've been using on this. I don't have a list of results. All I have is a normal distribution curve that represents a large population. So if we were looking at, say, scores from all over the country, where we had like 50,000 scores, we wouldn't really be able to use a table like this and do it the way you've been doing it. We would have to assign a normal distribution to it, and we would have to do it the Z-way. Okay? And the Z-score is going to be our score, 87, minus the mean, 80, divided by the standard deviation, 15. So the Z-score needs to be, let's round that off and call it 0.5. Okay? So that would be our Z-score to represent that entire area. And now you go into a table, and when I look at a Z-score of 0.5, it tells me that 69% of the curve lies to the left of that. Well, based on my drawing, that sure looks right. In other words, this is, no, that 65% is not correct. And in fact, 69% doesn't seem right, because 95 would, yeah, it does. Yeah, it does. In other words, if our score was 95, then we would have 50 plus 32. We would be in the 82 percentile if our score was one standard deviation to the right, correct?
Mm-hmm.
And that's an important distinction. It's important you understand why that's 82%.
I just realized we just went 7 minutes over.
Oh, I apologize. I wasn't.
No, you're fine. I wasn't
keeping track of the time.
No, you're fine. I just didn't know if you had any later.
Let's call it a session.
Okay.
And let me just talk to you briefly about your schedule for this year. Are we always going to be on Thursday night at 5:30? Is that our?
Yep,
that's our new regular time. Okay.
Yep.
If I could get you to do one thing for me before next Thursday.
Yep.
Give me a day if you can. If you can't, give me a couple hours. Early in the book, I'm fine. It's when we get later when we get to chapters 6, 7, and 8, those, I'm going to need more advance. Although by then I will have read all of those also a second time. So I think I'm okay, but just as a favor, whenever you can send the stuff to me in advance, and as much advance notice as possible, the more helpful it will be.
All right, sounds good.
Okay. And I'm going to make a copy of the Z-table because I kind of think it's important to understand the Z-table without having it strictly on your calculator.
Yeah.
Okay, so I will talk to you next Thursday at 5:30, Cole.
All right, talk to you then.
Okay, bye-bye.
Bye-bye.